Friends, welcome to our channel Mathematics by Fanat. Today, let us see the first question of exercise 10.2 of circles. Prove that the perpendicular at the point of contact to the tangent to a circle passes through the center. First, let us draw a circle. And then let us draw a tangent. This is the center of the circle O. Let this tangent be AB. The point of contact BP. Let AB be the tangent. Just draw the radius OP. Let us assume a point X and draw a line passing through the point of contact. We have to prove that XP is perpendicular to AB, which implies angle XPB is equal to 90 degree. We know that angle OPB is equal to 90 degree. Since using theorem 10.1, radius of a circle is perpendicular to the tangent at the point of contact. We have assumed that angle XPB is 90 degree. We understand that angle XPB is equal to angle OPB is equal to 90 degree. This can happen only if point X lies over point O. So our assumption of X being in the center becomes true. Angle OPB and XPB can be equal only when the points O and X coincide, which implies us that point X passes through the center of the circle and point X is O. So therefore, the perpendicular at the point of contact of circle to the tangent to a circle passes through the center. This question can also be solved in another method. We'll see that also. Let us draw a circle. Let its center be O, and let us draw a tangent AB and the point of contact be P. Construct PQ perpendicular to AB, and it is passing through O. We know angle QPB is equal to 90 degree by our construction. We also know that angle OPB is equal to 90 degree. Since radius of a circle is perpendicular to the tangent at the point of contact, theorem 10.1. We know that angle QPB is equal to 90 degree as well as angle OPB is also 90 degree, which implies that they both are same and it passes through the center of the circle. With this, we know that perpendicular at the point of contact to the tangent to a circle passes through the center. Thank you. Happy learning. you.